Hi all, this is Mr. Yeager for chemistry. We are looking at acid and base reactions today. We are going to have to try to do some predicting products and what we call neutralization reactions, but the thing is they're all the same type of reaction, so we should hopefully get the trend of that. And the same thing goes with what we call these Bronsted-Lowry reactions, where we're identifying where the hydrogen is going and identifying acids and bases, and etc., based on what the chemicals are doing. So here we go. Again, presentation made by another wonderful chemistry teacher. So, neutralization reactions first. So, this is basically what happens with acids and bases. When you put an acid and base together, they will produce what we call simply a salt and water. Those are going to be our products. They will produce salt and water. Now, when I say salt, I'm talking about ionic compound salt. Okay, remember, a salt is any ionic compound, not just talking about table salt, even though the first example down there with HCl plus NaOH is forming table salt, NaCl plus H2O. But in the second one, where I have potassium bromide, KBr, that is also a salt. Okay, but the big things are, you always produce water. So like if I give you an acid and base and I go, what is it producing? You can always write down H2O first. Now there's a little trick I like to do with it, and I'll show you that you can do as well. And then you add in the other two elements, making sure to always write metal followed by non-metal. Now you do have to balance the charges and everything like that for that salt. The two examples here are easy because it's plus and minus 1, so they just form NaCl, KBr. But the other kind of thing, make sure to see here, this might be on another page in a second, is these are always double replacement reactions. Double replacement. Okay? Which means we are simply just trading out the two first elements with each other. All right? That's truly what is happening here. All right? And my little trick is, I'll go and mention it already, is instead of writing H2O, write it as HOH. That is still the correct formula. All right, we write H2O all the time, but hydrogen hydroxide is also water. Okay, that is H2O. This might be a little bit more useful when we start having to balance, because some people do struggle with the balancing where they're going, I don't see where I'm getting confused with where the hydrogens are. All right. When I balance this, I can now balance the hydroxides as themselves, and then the hydrogen as itself. So you'll see that little trick in a moment. Okay? So, here we go. We got some examples right away. Okay? So I have HCl, pretty fancy little font here, HCl plus CuOH2. So, what's going to happen is, I'm going to switch the two first elements. I do not bring along the subscripts. Okay, I do not bring along the subscripts, all right, unless they're part of the polyatomic, which that would mean the two would be inside the parentheses. It's not part of it. So this would become CuCl. Again, you got it. You can't write, one of the big mistakes is I see people write ClCu, and that's immediately marked wrong. Okay, you got to do the metal first, plus HOH instead of H2O. I write HOH. Now, just like in any predicting products, I need to write out the correct formula for CuCl. Well, because this is where the naming comes into place, this is copper 2 hydroxide, and I know that because there are two hydroxides. Remember, whatever the hydroxide number is the Roman numeral. That means this is plus 2, copper is plus 2, Cl is minus 1, and so this would be CuCl2. Then I have to balance, and I go, I have 1H, and this is where I'm like, don't look at the whole thing. Don't look at all of H2O or HOH, just look at the first H. How many H's do I have right here? I only have one on the left, I only have one on the right. Don't look at the OH. I know there's technically two H's. Ignore that, ignore that, ignore that. I'm telling you it's going to help. Okay? I have one Cl, but I have two Cl, so I do need to come back and put a 2 now in front of HCl, which now means I have two H's, so I'm going to put a 2 in front of that first H. Then I have one Cu, I have two OHs, and look at that, I have two OHs. So that's why I say it's a little bit easier for some people. Some it might not be as easy, okay? Some people like to leave it as H2O. I strongly recommend, and you're going to see me do all my practice problems, writing it out as HOH. So let's do a few more. I got H2SO4 plus NaOH. I'm going to alternate the two first elements. I'm not going to bring the two with me. So this is going to be NaSO4. Now why am I bringing the 4 here? Because this is a polyatomic. So SO4 plus HOH, not H2OH. Please don't bring that 2 over. HOH. Then I need to figure out my formula for this one. I only have to balance this one salt formula. I never have to balance HOH if I write HOH. Na is plus 1 off the polyatomic sheet. SO4 is minus 2, so this is going to be Na2SO4. All right? I'm fine with you putting the OH into parentheses, even though technically we are not supposed to. I'm not going to mark it on you. Okay? So I have two H's. I have one H. I'm going to put a 2 right there. I have one SO4. I have one SO4. I have one Na. I have 2. I need to put 2 there. I have 2 OHs. I have 2 OHs. And this should be pretty straightforward at that point. I mean, this one right here is probably going to get the largest numbers. So I'm going to bring over BA and PO4, and then plus HOH. All right, I need to balance this one. I almost skipped that. Balance BA, PO4. BA is plus 2 based on the periodic table. PO4 is minus 3. So this is going to be BA3, PO4 2. All right, that's the only one I have to figure out the charges of. All right, going to the beginning. I have 3 H's. I have 1 H. So I'm going to put a 3 there initially. I have 1 PO4, but I have 2 over here. So I need to come back and put a 2 here. Now I have 6. So I have to come back and erase this, and I need to put down 6 H's. I have 1 BA, I have 3. I need to put a 3 here. I now have 6 OHs, and look at that, I have 6 OHs. All right, one more. So double replacement, balance the charges of the salt, balance the reaction. This is going to be, and I'm going to switch it up here. It's fine to write HOH first, no problem. You're going to have HOH and then ALBR. Balance the salt, plus 3 minus 1. Crisscross, ALBR3. All right, let's start balancing. I have 1H, 1H, 1BR, 3BR. Need to put a 3. Now that means I have 3 H's. I have 1AL, 1AL, 3 OHs, 3 OHs. That's it. Okay? You can try some of these other examples if you want. All right, what about what we call Bronsted-Lowry reactions? Bronsted-Lowry. First off, what the heck is Bronsted-Lowry? Bronsted-Lowry is one of the acid-base theories that we have. There's actually multiple acid-base theories for how to describe why something's an acid. Okay? Each one has its own little unique things. Each one has its own problems as well. Okay, so that's why they're good, but there are limitations to some of them. This is one of the best ones, especially at the high school level. It's great even at the college level for the longest time. But basically, Bronsted said an acid is something that donates an H+. A base is something that will accept an H+. Okay, that is what we're looking at here. So acids donate, bases accept. Okay. So what we're going to do with that is we're going to be doing these little reactions that we're going to be able to have to identify which one's an acid and which one's a base. All right. When they donate, okay, when the acid donates the hydrogen to the base, you're going to form 2 new products. Well, obviously, we always form products, okay? And we're going to call them the conjugates. And the conjugates are what are made. So they're always the products. The conjugate acid is basically what is created after the base has gained an H+. The BL stands for the Bronsted-Lowry base. When the Bronsted-Lowry base gains that H plus, and that's what we write on the product side, that is now the conjugate acid. And then vice versa, the Bronsted-Lowry acid that lost the high H plus now becomes the base. They basically switch roles. Like, you're going to see how I'm going to try to connect and be like, we're going to have the acid, what does it become on the product side? And that's always going to become the conjugate base. So I'm going to call it ABCs because we're going to always have, when I connect them, ABC written between the connection. Okay? One other term that we can mention is we do have something called amphoteric. This means the substance could possibly be an acid or a base. What that means is it's able to donate an H+, but in certain conditions it will accept an H+. So it can definitely be either one of them, okay, an acid or a base. All right? And you see some examples down here. Water is probably your most important one to remember. Okay, water is absolutely amphoteric. And then any of these ions that have H in them, but a negative charge, they will be amphoteric because they can either give up their H, or because they're negative, they'll take in an H. So that's how you can identify if it's amphoteric. Okay, so water, or whether it's an ion, a negative ion with an H at the beginning of it. All right, so the big thing you're going to be doing. The big thing you're going to be doing is you're going to be given a chemical reaction. Now the nice thing is this one's already done, it's already balanced, and all you're doing is you're trying to watch where the hydrogen goes. You're trying to see which chemical on the reactant side is giving away a hydrogen on the, as it becomes products. And we're going to identify these as acid, base, conjugate acid, conjugate base. So it's a bunch of just labeling. You're not balancing, you're not doing any numbers, you're just labeling. So what I got here is this. So you can see, again, we got to make sure we understand, we should know this by now. Left side is my reactants, right side is my products. All right, I don't need to go over that a second time. Okay? All right, so acid and base are always going to be on the left-hand side. Conjugate acid and base are always going to be on the right-hand side. What I need to do here is basically, I need to look at each chemical. I'll do it one at a time. I'm going to look at HNO2. And again, some of you guys are going to get really fast at this and be like, I already know that's the acid because it starts with H and the other one doesn't. Yeah, you're right. But we're going to take our time because there are other ones that might not be as easy to notice because both chemicals might have H's at the beginning of them eventually. Okay? So I have HNO2. What I want to do is I want to connect that to what does it become? And again, the only thing that can change is it either can gain an H or lose an H. Well, if it gains an H, HNO2, it would become H2NO2. I don't see that over here. If it loses an H, guess what? It becomes NO2 minus. Okay? So HNO2 to NO2 is losing an H plus. OH minus is becoming H2O. It is gaining an H plus, which means the HNO2 must be giving the H plus to the OH minus, which means HNO2 must be my acid. Okay? And OH minus then must be my base. Okay? They have to be on the same side. Acid and base have to be on the same side. Then I basically, this is why I make the connection. Based on the definition, the acid on the other side becomes what's called the conjugate base, which means the other one becomes the conjugate acid. The idea is if I reverse this reaction, you can see I have the reverse reaction arrow on there. I know we've never seen that before. If I reverse the reaction, H2O is giving NO2 minus the H plus. So, and that's what's actually happening. It is true. This reaction is going both directions. There is a preferred direction for it to go, which would be in this case to the right. But there are some of the chemicals that are actually doing the reverse reaction. But this is where I mean you do ABC. The connection between these two has A, B, C. The connection between these two, OH minus and H2O, has A, B, C. Okay? You can never have it where you go over and you go, the acid becomes the conjugate acid. Then you don't have your ABCs. Okay? You need to have your ABCs. All right, next one. All right, we got the chemical here. Again, yes, if you want to find the one that has H out front. We're not going to trick you and not put an H out front. Obviously, the first chemical does have hydrogens, but none of them are in the front. But let's go through the normal method with it. Okay. This chemical, CH3NH2, clearly is becoming CH3NH3+. It is adding an H+. It is taking one. While H2O is becoming OH- and is losing an H+. Well, if the first chemical is gaining an H+, it's accepting it. That must be my base, which means H2O in this problem is my acid. The last problem was my base. So that's why it's amphoteric. The base becomes the conjugate acid. The acid becomes the conjugate base. Okay? These students generally do pretty stinking good on, unless they're just not at all paying attention. All right, so finally, slightly tricky one, because both chemicals have hydrogen at the beginning. So either one could be the acid. So I need to look at the full reaction this time. So HPO3 clearly is becoming PO3-. It is losing the H+, which means this must be the acid, this must be the conjugate base, which H2O must then be the base, and H3O+, you can see it's clearly becoming that, is the conjugate acid. So these can get pretty quick if you're doing well. Just be very careful and don't make some silly mistakes. All right, this one right here, H2O is becoming OH-. It lost an H+. That means it's an acid, and that this is my conjugate base, which that means this one's my base, and this is my conjugate acid. All right, maybe two more.
Good morning, Broncos. Today is Thursday, March 12th.
All right, a little interruption with some announcements there. So, for this one, did I do that one? Let me just go to this one, even if I did that one. All right, one of my last ones. HF is becoming F-. H2O is becoming H3O. This is losing the H+. This is gaining the H+. This must be my base. That's my acid. Acid becomes conjugate base. That becomes conjugate acid. All right, last one here. NH3 and H2O. NH3 is becoming NH4. H2O is becoming OH-. This is gaining an H+. This is losing an H+. If that's gaining, the NH3 is base. Its product is the conjugate acid. H2O is my acid. OH- is my conjugate base. So that's basically it. Okay? Very good. Thank you.